Okay, so part number 2 of this worksheet. So what we're working with now is we are asked to give an example of an aldehyde. And as I said earlier, I'm going with pent everything. So 1, 2, 3, 4, 5. My aldehyde group is here. On my last carbon, we're drawing in the hydrogen just to make it explicit that this is an aldehyde group, and we've got our double bonded O. So remember, that is our aldehyde group. Whatever it interconverts to is going to be there on the new compound. Using the synthesis map then, we're asked what happens if we have an interconversion through oxidation. So we have our aldehyde group here, and oxidation is here again to a carboxylic acid. Okay, so carboxylic acid is a really similar functional group. The only thing that's going to happen is that this part is going to become an OH, and that makes it the carboxylic acid. In terms of naming, aldehydes end in al, so we had pentanal, and carboxylic acids, as you know, end in oic acid, so then we've got our pentanoic acid. Again, using biovia draw, you can double check that with your naming function in there. Okay, so for the next one, we're asked about, once we've got this, we're asked about something called an addition-elimination reaction. I'm going to show you how this works. So quite scruffily, I've drawn 2 pentanoic acids, 2 molecules of pentanoic acid, and I've drawn them with their carboxylic acid groups kind of facing each other, because what's going to happen in this reaction is that these 2 molecules are going to get stuck together into one big molecule. That's called an addition. In the process, they're going to lose a water molecule. That's the elimination. So, for example, these atoms are going to come away as water. Sorry, oxygen. So we're going to get a water molecule coming away. This is going to join up here. Okay, and what we end up with is called an acid anhydride. This particular acid anhydride is called pentanoyl pentanoate, pent, because I was starting with a 5 carbon molecule. So pent is in my name, but it won't be in yours. Yours will be named differently to reflect whether you used perhaps a 2 carbon, no, sorry, it's 3 or above, isn't it? A 3 carbon starting molecule, or 4 or 5, and obviously that would be at both ends. These would be different depending on what starting molecule that you have chosen. Okay, that's it for that one.